Let's talk about an important concept in Golang that's a little different than Python. So Golang has sort of a concept of pointers. I say sort of because there's definitely a pointer there. They talk about pointers as operators for pointers, but they're not quite like C pointers. You can't, C pointers are literal memory references that you can add to and move it and walk memory by moving the pointers around. You can't quite do that with Golang because Golang is still a garbage collected language. So the pointers are not absolute, but they are there and they are important because when you're dealing with an object, specifically something like a struct, if you pass the struct as that struct, you're doing a pass by value, which could be a very large memory copy if you have a very large struct. However, you pass it by the pointer value, you're only passing a reference to it. There's pros and cons to working with structures this way, but it's simply a fact of life in Golang that you have to understand pointers. So like in C, C++, you can reference an object's memory location, and I'm putting that in air quotes because really it's referencing the reference to the object in Golang by the ampersand operator, which is how you get the pointer value in C or C++. And if you had the pointer and you want to dereference directly to the object, you would use the star. However, in Golang, you really don't need to do that very often. If you ever program in C and C++, you might remember that to access a member of a structure in C or C++, you would have to do funky things like, here, let's go here. You have to do funky things in C and C++, like dereferencing the pointer, of course, in parentheses, and then doing the accessor to the field, or do an accessor like that to the field. But you don't need to do any of that with Golang. Golang, whether or not you have a pointer or not to a structure, you can always access the members of that structure with simply a dot operator. So let's look at some examples. Here's our basic struct that we're working with. It's got it's got two fields in it. One we're going to be working with called exported data. We'll talk about the difference between internal exported data on another video. And we can access the exported data by simply doing x dot. So we declared the variable x of type sample struct. We can access its members by doing a dot operator and set values to it. Now, if we pass it by value, so we go to pass by value, you see we just take in a reference to that structure. We can set the data in there and work with it all day long. But when the structure ends, this was a copy that was made of that entire structure. When this function ends, that copy is gone. So no changes will be reflected out. However, if you pass it by reference or by a pointer, that's another way of saying that, you use the pointer notation. So this is, I'm passing a reference to a sample structure, and I can make changes to it. But when I leave, all I did was change the reference that was passed in. So all those changes are reflected in the root structure. So you can see, I'll print out, we'll start with export data. We'll make some changes and we'll see what it looks like after the pass by value. And we'll make the change down and pass by ref and we'll look at it afterwards. And you can see right here, the output from the run. At the start, we print out that. In the change function, we've changed it. We print it out, and sure enough, in the change by value, it's printed out as change. But when we come back out and print out after that change, it's back to start where we started. Now, when we pass it into the pass by ref, we change by ref. And as we exit that function and come back here, you can see it is indeed still changed by ref because we changed the reference object, not a new copy. We changed the original one that was passed to us by value. This is important to note. This is a key item. So if you're ever working in golang with, well, you will be working with structures, we saw that, but other things are always work that way. Like when you pass an array or a slice around, it's always passed by value. Now, if you have hard values inside there and you copy those around, you're moving a lot of data, so you don't want to do that too much. But arrays, maps, slices are always passed by reference. They are by their very nature a reference to a chunk of data allocated. Notice I'm not talking about heap versus stack here, because we don't really think about those in the Golang world, because Golang decides where things are allocated. They can be moved. So I'm not talking about heap or stack in this context. There are stacks, there are heaps, but you don't have to think about them in Golang. So this is kind of a brief introduction of pointers. I hope it's not too terse. I'm assuming you've already played with pointers or have an idea what they are. Thanks for listening.